A compound by name rhamnose. Formula C6H12O5. C6H12O5. Whether it is fitting in this formula or not. CXH2OY, whether this will fit in this formula or not. I am writing glucose, man. What is glucose? C6H12O6. Can I write as C6H2O 6 times? Whether it fits in this formula or not. That's why we call it as carbohydrate. Then what is fructose? Fructose formula also same. That also fits in this formula. So whichever fits in this formula, we call it as carbohydrate. Correct or not? Now observe this rhamnose. Do this fit in this formula or not? So rhamnose do not fit in this formula, but it is a carbohydrate. Hello? Do not fit in this general formula, but it is a carbohydrate. Stop talking. I am taking one more compound, acetic acid. What is formula of acetic acid, sir? We write as CH3COOH, or we can also write as C2H4O2. Can I write as C2H2O 2 times? It fits in this formula, right? So it will fit in the formula, but it is not a carbohydrate. That's why. Can I say carbohydrates means carbon and water processing units? Can I say carbohydrate as carbon and water processing units? We cannot say it. Reason? Many compounds follow it, but there are few compounds which are carbohydrates but doesn't fit in this formula. There are some other compounds which fit in this formula, but it is not a carbohydrate. That's the example we have taken these two, right? That's why which is better suitable definition. We can define them as many OH group possessing aldehyde or ketose, or it may produce such units on hydrolysis. We can call them as carbohydrates. Is it clear? Response, sir. Carbohydrates are also called as saccharides. Saccharide is a Greek word for sugar. So I am taking that statement. Carbohydrates also called as saccharides. Saccharide is a Greek word. Saccharon means sugar. Saccharides are classified into many types based upon how many units are generated on hydrolysis, right? So saccharides are classified into different types based upon hydrolysis. As monosaccharides. What are monosaccharides? They will not break down on hydrolysis. So they cannot be hydrolyzed further. They cannot be hydrolyzed further. Online following or not?
Yes, sir.
Yes, sir. All are yes, sir.
We call them as monosaccharides. Example: glucose, fructose, mannose, galactose, etc. We call them as monosaccharides. So in this way, approximately 20 monosaccharides are known. So they do not undergo hydrolysis. We call them as monosaccharides. Now, oligosaccharides. Oligosaccharides. On hydrolysis, they will give 2 to 10 monosaccharide units. On hydrolysis, they will yield 2 to 10 monosaccharide units. We call them as oligosaccharides. If it is having 2 monosaccharide units, if it gives 2 monosaccharides, then it is called disaccharide. Then it is called disaccharide. If it gives 3 such units, trisaccharide, and so on. This is second classification: monosaccharide, oligosaccharide. Third one, polysaccharide. I will take few more examples, sir. For example, if I take sucrose, on hydrolysis, acid hydrolysis, sucrose gives glucose and fructose. So how many monosaccharide units I am getting? That's why sucrose is a disaccharide. So can I call sucrose as a oligosaccharide? No. In the same way, if you take maltose, malt, this on hydrolysis gives 2 glucose units. Therefore, it is also disaccharide. Lactose on hydrolysis gives glucose plus galactose. Glucose plus galactose. That's why lactose is also disaccharide. I am discussing this. Whether you know what is glucose, what is mannose, what is maltose, what is. Why I directly started this? We discussed all these sugars in stereochemistry itself. Listen. What we call this as ethylene glycol. Correct? Huh? Ethylene glycol. This is called glycerol. Ethylene glycol, glycerol. Instead of this CH2OH, I am taking aldehyde. I am oxidizing this group to form aldehyde. Remaining I kept as it is. So second carbon have OH group, correct? And bottom carbon is CH2OH, correct, sir? This is glycerol. Only one OH group of glycerol got oxidized to aldehyde. This is called glyceraldehyde. Online, someone respond. Is it
Yes,
clear?
sir.
Yes, sir.
Ethylene glycol,
Clear.
glycerol, right? This is glyceraldehyde. What is the use of this glycerol? How you got this glycerol? Any oil, right? Or fat. If I do hydrolysis in presence of base, we call this as saponification, right? So CH, CH2, O, C double bond O, O, C double bond O, O, hydrolysis, what happened? This on hydrolysis, base hydrolysis. What happened? This is ester, no? Three times some carbon chain, CO, O minus. If I take NaOH, I will get Na. If it is potassium hydroxide, K. Right? Sodium or potassium salts of fatty acids are nothing but called as soap. This is called soap. What is this one? Glycerol. How we got glycerol and soap? From oils. Oils on base hydrolysis. What type of base I am using? And what type of oil? Rice bran oil, right? Any oil. And what type of base? Lithium hydroxide, sodium hydroxide. Sir, internet problem, sir. Sir, in almost every classroom. Once check you downstairs only. LAN is not at all working. Wi-Fi is getting disconnected continuously. Yes, sir. Online students, am I audible now?
Yes, sir.
Right, sir. Then we will continue. So I am taking glycerol and I am adding a mild oxidizing agent. Right? Mild oxidizing agent will oxidize only aldehyde group to acid. Is there any aldehyde group in it? No. Correct? I am taking one more mild oxidizing agent. So that I will oxidize only one alcoholic group, not everything. If I add HNO3, concentrated nitric acid, both primary alcohols will be oxidized to carboxylic acid. Right? So what I want to do is, I want to oxidize only primary alcohol, that to one. So I am adding measured quantity of copper. Then I will oxidize only one alcohol group to aldehyde. If I only oxidize one aldehyde alcohol group to aldehyde, can I get this one? So what we call it as glyceraldehyde. Glyceraldehyde is taken as a reference for giving stereochemistry, for doing stereochemical studies. Right? This is taken as a reference for all stereochemical studies. If I have this OH group, can I call this as first priority carbon 1, second, third? From least priority carbon, next carbon, if we have OH group or functional group, towards right side, it is called as D, capital D. If it is towards the left side, L. So we call this as D-glyceraldehyde. So D-glyceraldehyde is taken as a reference to do stereochemistry of all stereochemistry of all organic compounds. We will take D-glyceraldehyde as a reference. Right? Instead of this, if we have carboxylic acid here, COH here, and here if you take NH2 group, instead of alcohol, I am taking NH2 group, sir. Then it is called amine and acid posting group. We call it as amino acid. Right? Can I call this as functional group and this carbon as alpha carbon? On alpha carbon, amine is present. That's why it is called alpha amino acid. Clear? In alpha amino acid, the smallest alpha amino acid is glycine. Correct or not? So CH2, COOH, NH2. Correct or? So smallest amino acid, this is glycine. How many such amino acids we have? 20. Right? 21st amino acid is also found in bacteria. Another is there. If it is selenium is present as metal, then it is another amino acid, 22nd amino acid. Correct or not? If a 23rd amino acid is present, then definitely not human. Correct? Response, sir. To my knowledge, right? So some people will say in the blood of here we found 23rd amino acid. Correct or not? Making everyone as fools. Right? Reality is different. If you are human, you should possess 20 amino acids. Remaining all things are nonsense. Okay, leave it. Now coming to this. This is alpha amino acid. If you have another CH2 group, we call it as serine. Having function group on left side. That's why it is called L-serine. So to study amino acids, L-serine is taken as a reference. Correct or not? Response, sir. So while you are studying stereochemistry, configurational, correct or not? Configurational or not? Conformational means if there is free rotation, conformation. If rotation is restricted, then it is configurational. Correct or not? Now we are taking D-glyceraldehyde as a reference to study all carbohydrates. Now I am placing one more carbon between these two. Correct? Now tell me, do this have many OH groups in it or not? Alright, two OH groups. So it is polyhydroxy aldehyde. So can I call it as sugar, carbohydrate? Correct or not? The definition of carbohydrate, man. What is it? Polyhydroxy, optically active, maybe optically active, polyhydroxy, aldehyde possessing or ketone possessing compound is called. So it is a carbohydrate, right? Now I am placing one more carbon in between. Same thing I am taking. Aldehyde. Hereafter, directly I will write CHO here, aldehyde. Okay, well? I introduced one more carbon in between. I have introduced one more carbon in between, right? Here I kept this OH group as it is. So now tell me whether it is a D or L. D only, because this is first, second, third, fourth. From last, second carbon is having hey, what is the condition? From last carbon, second carbon should have OH. 1, 2, 3, 4. This is last carbon. Or we can call it as last chiral carbon. This is last chiral carbon or not? 1, 2, 3. This is the last chiral carbon. On last
Screen
chiral
is not.
The screen is not visible, sir.
Right. Any questions in it? Erythros and trios? If I am adding one more carbon. Response, sir. So in erythros, I kept one more carbon. Ribose, arabinose. In trios, again connected. At least 10 times it got disconnected and connected. Now, trios. No, don't restart now. Again, class will be gone. Right? Without restarting, try to do something. After now you can do, I think now break only. Oh, yeah. Now coming to trios. In case of trios also, xylose, lyxose. Can I call these are 4-membered chains? So we call them as tetroses. These are all 5-membered pentoses. These are all 6-membered hexoses. Later only. Tomorrow. You give tomorrow. Tomorrow. Right? Any questions about hexoses now? Right? Allose, altrose, glucose, mannose, glucose, iodose, galactose, talose. All these are obtained from P-glyceraldehyde. Same way from L-glyceraldehyde also we can create another 8. We stopped at 6. Same way with 7 heptoses, octoses, we can create or not. So all those are carbohydrates one. Our study is restricted to hexoses. We are studying mostly for 6-membered chains, hexoses. Clear? Now I am coming back to this. Is it clear now? Why we are studying only glucose, galactose, glucose, fructose, right? Because we are restricting our study for 6-membered monosaccharides only, right? If 2 such 6-membered monosaccharides connect with each other, we got disaccharide. Correct or not? If in such a way up to 10 monosaccharide units are connected, then we call them as oligosaccharides. If it is more than 10, then it is called polysaccharide. So third type of classification, polysaccharides. Polysaccharides. Now tell me what are polysaccharides, sir? What are polysaccharides? On hydrolysis, they yield. On hydrolysis, they yield many monosaccharide units. Many monosaccharide units. Example. What is starch? Response, sir. Already we are discussing now about starch. Starch is a polysaccharide, right? Cellulose. Good. Cellulose. All the things which are generated from plants, all are polysaccharide. Cotton, polysaccharide, right? So cellulose, glycogen. Glycogen is called as animal starch, right? Glycogen, right? Gum, etc. All these are polysaccharides. Now, another important note. Monosaccharide and oligosaccharides. Monosaccharide and oligosaccharides. These are crystalline solids. These are crystalline solids. They are readily soluble in water. They are sweet to taste. And hence we call them as sugars. Oligosaccharides. Sorry, not oligosaccharides. Polysaccharides. They are also sugars only. But we don't call them as sugars. Reason, they are not sweet in taste, right? So they are amorphous, powdered form. Amorphous, insoluble in water. Insoluble in water. Tasteless. And hence, we call them as non-sugars, right? In fact, cellulose and starch, chemically same. Only difference is that is alpha form, this is beta form. We can digest alpha forms. We cannot digest beta forms, right? But both are glucose units only, right? Polymer of glucose units, right? Now, another note. What is the difference between reducing sugar and non-reducing sugar? What is the difference between reducing sugars and non-reducing sugars? What are reducing sugars? They should possess pre-OH group, or we can call it as hemiacetal group. Yes, sir. LAN is working. Right? So they should possess hemiacetal group. What is hemiacetal group? What is hemiacetal group? Carbon connect. See how many times I am discussing hemiacetal group. What is hemiacetal group? Carbon connected to hydrogen, carbon connected to ether, connected to OH group, and one more carbon chain. Carbon connected to either chain, carbon connected to hydrogen, carbon connected to carbon and OH group, right? Due to presence of this OH group, it is behaving as reducing sugar, right? They give positive Tollens test, positive. Fehling's test, positive. Benedict's test, positive. Selivanov's test, positive. Response, sir. Selivanov's test positive or not? But I cannot take Selivanov as authenticated. Reason. Selivanov's test gives positive for ketosis only. There may be reducing sugars with aldehyde group also. That's why I'm not taking it. Clear? Response, sir. Non-reducing. What are non-reducing sugars means? No positive test with. No positive test with. Failing, Benedict, Equivalence. Right? Example. Sucrose. Sucrose is a disaccharide, right? Which on hydrolysis gives monosaccharides. Both monosaccharides are reducing sugars. But when they connect through this OH group, right? That's why it is not reducing sugar, because that OH group is not free. Response, sir. Starch, non-reducing. Cellulose, non-reducing. All these are polymers. Now tell me how they are getting connected. Through this active OH group only they are getting connected to form longer chains, right? Cellulose, glycogen, etc. All these are polysaccharides, but non-reducing sugars, right? Due to presence of acetal group. What is acetal group? This is hemiacetal group. Now what is acetal group? What is acetal? Convert this OH group also as ether group. So carbon, OC, OC. Now, do this OH group is free or gone? Now we call this as acetal. So presence of acetal group fails all those tests. Therefore, it is called non-reducing sugar. Any questions, sir? Reducing sugars, non-reducing sugars. Monosaccharides, oligosaccharides, polysaccharides. Polysaccharides are not called as sugars. Up to 10 monomeric units form longer chains. Then we call them as sugars. Respond. Any questions in it? Online, someone respond, sir.
Yes, sir.
Now, in this chapter, we study purely about monosaccharides, right? So our next slide heading is monosaccharides. In this chapter, we are studying only about monosaccharides. Based upon the functional group present, these monosaccharides are again classified into two types. If they have aldehyde functional group, aldoses, ketone functional group, ketoses, right? So monosaccharides are classified into two types: aldoses, ketoses. I will give the break, man. Let me complete the classification, then I will give the break. What are aldoses? Aldoses possess aldehyde functional group. Possess aldehyde functional group. What are ketoses? They possess ketone functional group. Means along with the definition, what is it? Polyhydroxy aldehyde possessing compounds are aldoses. Oses. Polyhydroxy ketone possessing functional groups are ketones. Now, if it is only having 3 carbons continuously, example, glyceraldehyde. Just now we have seen now aldehyde, CHOH, CH2OH. Is it glyceraldehyde or not? But how many carbons in continuous chain? 3. Therefore, we call it as a triose. From 5:30 class, go. Already last time we told now. Whenever chemistry is there, class is from 5:30. Sit. Right? Response, sir. Is it monosaccharide or not? Many OH groups, aldehyde, so aldose. But 3-membered. So it is called triose. If it is 4-membered, tetrose, 5-membered, 6-membered, and so on. So 3-membered polyhydroxy aldehyde possessing group, we call it as aldotriose. Any questions in it? Now tell me, what is C4? What we call it as? Aldo tetrose. C5, aldo pentose. C6, aldo hexose. In this chapter, we majorly concentrate on aldohexoses and ketohexoses, right? If it is C7, aldoheptose, right? Example of aldotriose. Give one example, sir. Glyceraldehyde. If this glyceraldehyde having OH group on last chiral carbon towards right side, D form. If it is on left side, L form. Now, aldotetrose. We have seen two. Erythrose, triose, right? If you have both OH groups on same side, erythrose. If these two OH groups are on opposite side, triose. So I am writing example. Erythrose or triose. Aldopentoses, arabinose, ribose, xylose, lyxose. Response, sir. 4 we have seen, na? Stereochemistry. Ribose, arabinose, xylose, lyxose. Correct or not? All have 1, 2, 3, 4, 5. So all these are pentoses having aldehyde group. That's why we call them as aldopentoses, right? So arabinose, ribose, and so on. Hexoses. 8 we have seen. Response, sir. We have seen 8 now. All altrose gladly made gum in a gallon of tank. Correct? Allose, altrose, glucose, mannose, glucose, indose, galactose, talose. 1, 2, 3, 4, 5, 6, 7, 8. Correct? Again, I will show that. Observe. All altrose gladly made gum in a gallon of tank. Allose, altrose, glucose, mannose, glucose, idose, galactose, talose. Right? All these are hexoses. Respond. So I'm taking only one example. Can I take glucose as an example? Right? Now, aldoheptoses, pseudoheptose. Pseudoheptulose. Example of aldoheptoses. Yes, sir. Now, ketone processing. If there are 3 carbons with ketone group, what do we call it as? In the same way, ketotriose. C4, ketotetrose. C5, ketopentalose. Okay, ketopentose. C6, ketohexose. C7, ketoheptose. Example. Dihydroxyacetone. Dihydroxyacetone. What is that dihydroxyacetone, sir? C double bond O. CH2OH. CH2OH. Is it polyhydroxy compound or not? Having many OH groups or not? And a keto group. And a continuous carbon chain. So this is an example of Response, sir. Triose. Is it triose or not? Ketone possessing triose. If we have one more carbon, keto-heptose. Sorry, keto-tetrose, keto-pentose, and so on. Example of keto-tetrose. Erythrulose, ribulose, fructose, pseudoheptulose. So these are all examples of ketoses. Any questions in it? No need to have the diagram, right? No need to discuss, right? No. Can I call erythrose and threose as C2 epimers? What are epimers? Having same configuration at all carbons except one carbon. They are called as epimers, right? C3 epimers, C2 epimers, C4 epimers. C1 epimers are also called as anomers. Understood. I will take diagram directly. Who can I call it as? Glyceraldehyde. Now I got it. Done, sir. No. Last chiral carbons, OH group is on right side, so D form, glyceraldehyde. We placed one more carbon here. If I place one more carbon here, correct? On that carbon, I can place OH group towards right side or left side. Both are possible or not? Response, sir. So this is a triose. These two are tetroses. So erythrose and threose. Observe erythrose and threose carefully. First carbon, no need of configuration because sp2. Second carbon, OH group position is different. Third carbon, same. Fourth carbon, same. So they have difference in configuration only on second carbon. Therefore, erythrose and threose are called as C2 epimers. Alright. They have difference in configuration at second carbon. So this is first carbon. This is second, third, fourth. Correct or not? So I am writing that point. D erythrose. Control Z. D erythrose and D threose. These two are C2 epimers. Any questions in it? No questions, no? Now coming to this. What about ribose arabinose? ribose, arabinose. C2 epimers again. Correct or not? Now, allose, altrose. Allose, altrose. Allose, altrose. C2 epimers. Any questions? No. We have mannose, glucose, galactose. These three are important for us. Right? Ribose to some extent. That too, while we are studying RNA and DNA, we will use this ribose. In ribose, if I decrease one oxygen out of this OH groups, if I remove one OH group, then it is deoxyribose, right? Otherwise, ribose, right? Now, glucose and mannose. Response, sir. D-glucose and D-mannose. What are they? Hey, observe carefully. Glucose and mannose. From one, no difference. Second carbon, difference is there. Third, no difference. Four, no difference. 5, 6. So these two are C2 epimers. Are you able to understand what are epimers now? Having same configuration but different configuration, having same configuration at all carbons except one carbon. So they are called as epimers. Now, glucose and galactose. Glucose and galactose, sir. D-glucose and D-galactose. What are they? Glucose and galactose. First carbon, second same, third same, fourth. Right? So these two are C4 epimers. Any questions? Now, mannose and galactose. D-mannose and D-galactose. Mannose and galactose. First carbon, second, third, fourth. Second difference is there. 4 also difference is there. So they are not epimers at all. Reason. Epimers means only at one carbon if there is difference in configuration epimers. So we cannot bring any relation between them. Over. Any questions? Right? So among hexoses, we need to remember these three only. Among pentoses, only one. Among tetroses, 2. Among trioses, only 1. These things we need to remember. Any questions? No. What are C1 epimers? C1 epimers. We call them as anomers. C1 epimers. We don't call them as C1 epimers. We call them as anomers. Means if they differ in configuration only on first carbon. Right? Any questions? Response, sir. Any questions? Very, very, very important reaction, sir. Now go for break. After break, we will discuss this one. Lowry, D, Bruin, Van, Eckstein reaction or rearrangement. Lowry, D, Bruin, Van, Eckstein rearrangement. Right? Just adding base to it. Take any carbohydrate, add base. Then we call this as Lowry, D, Bruin, Van, Eckstein rearrangement. Right? Remember, we are not discussing anything extra, whatever present in your NCERT textbook, as it is, all points we are discussing. Right? Repeater students, don't say something new. Right? After going home, open your NCERT textbook and check. You will find it. Right? Okay, sir. Go for break. Online students, join in the same link. Continue in the
Okay,
same
sir.
link, sir. Stay in the same link. Go for break. After 5 minutes, we will start. We will continue. This week,
Thank you, sir.
please